Before we start the maths, let's explore why roads go up into the sky. If we take a straight line and we put a point in the middle and we measure the angle between this line and this line, it is 180 degrees. So we're just establishing the fact here. If you take the standard armour block, which everyone starts off with in the game in general, the large one to start building a base, it is a perfect cube. This means that every angle on this cube, regardless of where you measure it, is always 90 degrees. So when you add two blocks together, join them up, you add the angles and you get 180 degrees, and 180 degrees is a straight line. Now let's have a look at our Earth. The Earth is a sphere. Sure, we've got mountains, lakes and everything else, so it probably does look a bit squiggly, like my semicircle here. But if we ignore the mountains and the valleys and lakes and everything else we can find, we ignore those, we have a sphere. So this is part of that sphere, and we start building our road from here, just a straight line. So when we look at it, we find that the road goes up into the sky, because when we're looking at it, we're probably here looking up to it. So we think that the road goes up into the sky. This is actually not true. What's happening is the Earth is falling away from the road, and this is why this happens. It's because all the angles add up to 180 degrees, which gives us this straight line. So now that we've established that fact, we can now move on to the rest of the maths. Here is the representation of the Earth. Our base is somewhere around here, and our cobalt is somewhere over here. When we look at it from the base, the distance between the base and the cobalt is 5.4 kilometers. Let's call it 6 kilometers. And we know that if we don't want to drill through this particular line or through the surface of the Earth, then we're going to have to come down a certain way, and we need to find out what that distance is. So if we look down here, this is the centre of the Earth. We can draw a line from here to here, and we know that the Earth's diameter in the game is 120 kilometers. This means that the radius is going to be half that, which is 60 kilometers. If we now draw a line up here, this is also a radius, so that's also 60. But here we can see we've got a triangle, and it's a right angled triangle, which means we can use Pythagoras' theorem to work out this distance between the centre of the Earth and where we need to dig to. Pythagoras' theorem says that the square on the hypotenuse, this one here, is equal to the sum of the squares of the other two sides, which is that squared plus x squared. So we can find out what x is. Once we know what x is, we can subtract it from the radius and get our depth here. So let's turn the triangle round and redraw it, and let's look at the math. So here is our triangle. Not very good at drawing straight lines. Oops. Let's get rid of that. Okay. I'll change to black. Now then, this is the hypotenuse of the triangle, H, but it's actually the radius, so let's call that R, and that is 60 kilometers. It is a right angled triangle. This distance from here to here, we said we were going to call 6 kilometers, and this is the edge that we want to find, this length. So as I said, Pythagoras has said that the hypotenuse, which is r squared, equals the sum of the squares of the other two sides. So that means, let's call this one d squared plus x squared. Now we want to find x squared. Actually, we want to find x. So how do we do that? Well, if we subtract d squared from both sides of the equation, we'll end up with x squared. So r squared minus d squared is equal to x squared. The equation is still balanced. If we want to find x, then we take the square root of both sides, because the square root of x squared is x. So we can then say that the square root of r squared minus d squared equals x. Let's change that around and plug in some numbers. X equals the square root of 60 times 60 minus d, which is 6 kilometers, 6 times 6. So x will equal square root of 6 times 6 is 36 plus 2 zeros minus 6 sixes are 36. So x will be equal to the square root of 3564. And if we use a calculator, x is equal to 59.6992. So our base is here on the surface, our cobalt is here on the surface. If you remember, we needed to find this distance. So if we take this value here from 60, it will give us how far we need to drill down, or drill up in this case. So 60 minus 59.6992 is equal to 0.3008 kilometers. So we want that in meters, so we just shift the decimal point over a couple of places, so that will equal 300.8 meters. So I thought I had drilled down enough, but obviously I haven't. But to be on the safe side, I'm going to say I'm going to drill down to a depth of between 320 to 340 meters to be on the safe side. That's quite a distance. So let's go into the game and find out where I am. Here I am at the point where I think I need to drill from to go across to the Cobalt. As you can see, if you can just make it out, the base marker is around about 60 meters. And of course, from the math, we have discovered, to my horror, that this is not right. In fact, we need to be around 320 to 340 meters. So I'm going to have to drill down a lot further, dismantle all this and take it further down. Due to the magic of video editing, we can do this very, very quickly. So I'll see you when it's done.